Hello everyone, my name is Zakir and this is my Physics 2212 Lab number 2 presentation. So as an introduction, the purpose of the lab is to refine the computational model used in the last lab to more accurately calculate the charge Q and the electric force of the piece of U tape. And we're going to do this by treating the tape as multiple or 100 point charges instead of just one. And the main findings from this lab were that for the situation where the net force is equal to zero, the electric charge is 2.96 times 10 to the negative 8 coulombs. So by increasing the number of point charges, the accuracy of our approximation is improved. Some fundamental principles. One is Coulomb's law, which allows for the calculation of electric force given the charge of two particles and the distance between them. Newton's second law allows for the calculation of a net force given acceleration of the object mass. In this lab, no acceleration, so no net force. Newton's third law allows for the determination of the charge of one piece of tape, knowing the force exerted on by the other piece of tape. And the concept of superposition, which allows for the calculation of a net electric field by summing all of the individual electric fields. Some assumptions, we're going to ignore error resistance, but we are not going to treat the long tape as if it was a point charge. That was lab one. We are going to assume that each U tape has each the same amount of charge and it's evenly distributed. And we are going to uh, assume that the sum of the charge at each location is equal to the total charge. And all assumptions are potential sources of error because of this, because none of these assumptions are perfectly true. And for our model, each piece of tape is modeled as several point charges. So the experiment description, our system is tape B, or the second piece of tape, and the surroundings is everything else, including the first piece of tape in Earth. The initial conditions is we have two pieces of neutral tape that are equal length and a third piece of tape, which can be any size, just as long as the first two pieces of tape it can be longer. The procedure, tape one and tape two are ripped off of tape three, which lies flat on the desk. Then tape one is brought close to tape two until this piece of tape started to float and then recorded that distance. So we found that tape 1 and 2 were 0.22 meters long, and it started to float when separated by a 0.029 meter distance. Some calculations using the density of tape, we can find the tape mass to be 0.00022 kilograms. The gravitational force was 0.00216 newtons in the negative y hat direction. And because forces are equal opposite, electric force is positive 0.00216 newtons. And then we can find Q by readjusting Coulomb, by manipulating Coulomb's law, and Q is equal to 1.42 times 10 to the negative 8 coulombs. For the glow script, the top code is just the electric fields calculator, which is the same as the one that's used in lab number one. And then the second block of code iterates through each piece of tape to be able to determine the net electric force. And it does this by adding the previous electric field and then adding the electric field caused by the next particle. So it kind of does this in this stepwise fashion by using two for loops. And using the value found in lab number one with a Q value of 1.42 times 10 to the negative 8, we can see that the electric force and the gravitational force are not equal. The gravitational force is much stronger. So, using a guess and check method, uh, in order for these forces, electric and gravitational, to cancel each other out, we need a Q value of 2.96 times 10 to the negative 8 coulombs. So for the discussion, this method is more accurate than lab number one because the sum of 100 point charges is more accurate than one. And it's still not perfect because the model can be improved if you just increase n. Some sources of error is the charge of each piece of tape might not be the same, and there's likely not a perfect distribution of charges. That's a very idealistic scenario. So for the discussion questions, if we model it as a single point charge, like in lab one, well, the point charge yields a significantly lower value for the electric charge than the line charge because it doesn't take into account the x components that ultimately cancel each other out. And why do these estimates differ? Which one's more likely to be close to the real value? The line charge is likely to be far more accurate, and the length of the charge is not like negligible in this scenario. Therefore, the line charge is different. To conclude, several fundamental principles, including Newton's second law and Coulomb's law, are involved in the calculation of electric force. Point charge models and line charge models yield significant differences in the calculation of electric charges, fields, and forces, and line charge models often offer a better approximation of the total electric force. Thank you for listening.